Kubernetes node rotation is an extremely important process uh, in which you need to upgrade your node AMIs. There might be many reasons for this kind of upgrade. There might be compliance and governance region where you need to fix some vulnerabilities on your Kubernetes nodes, or you simply want to upgrade your Kubernetes cluster and roll out new version of AMIs. So today I'm going to spell out the detailed process on how to roll out the new AMIs on the Kubernetes EC2 nodes without any downtime. So we are going to use Terraform, um, which basically provisions the Kubernetes cluster and the node groups. Uh, so without any further delay, let's have a look at the Terraform code for EKS. First of all, we need to understand that our Terraform code should be written in such a way that it makes the changes in an automate, that it is easy to make the changes in an automated way. This is the Terraform code which we use to provision the Kubernetes cluster. So if you have a look at it, it has a module for EKS, in which we are passing certain information such as source, module, subnet IDs, IAM required, EKS KMS resources is equal to secret, which basically encrypts our secrets at the in the at the rest. Sorry, yeah. And then we have a module for the node group as well. So this module basically reads the local variable called node group. We can configure as many node groups as we want in this local node group variable, and then the module EKS node group will will iterate over that node group variable using the for each loop and create the required node group templates and the auto scaling group behind the scene. So the first step of adding the new node group will be to add a new node group configuration in this local variable. Now you might argue that in the managed node group of Terraform, in the managed node group of EKS, we can simply change this configuration in at the place of 04, we can do it 05, and the new AMI ID, let's say it is ABCD and 02 version, whatever is our new AMI, and we simply do Terraform init plan and apply. Because it is a managed node group, so EKS will automatically take care of the pod migration by doing the node cordon and node delete. But actually, this is not a smooth process. Sometimes there are some limitations such as pod disruption budget, or we might want to handle node termination in a certain way. We might want to put some checks. We might want to monitor the node deletion and cordon one by one to meet our custom requirements. So simply changing the node group name and applying the Terraform does not ensure that our pod migration is going to be smooth during the AMI handover. So there is a little bit of custom logic required. There is a little bit of the monitoring and checks that we need to specify. So I'm going to spell out all those changes, how you can smoothly roll out the new node group. So let us try to spell out. So our first step would be to create a new node group by adding the the configuration under local node group variable. So if we talk about the automation, how do we automate this step? This can be easily done using a Python script. So Python script will read our existing configuration and will add a uh, new numerical number after our node group. Let's say if it was 04 initially, now it will add a new node group with the name 0403. It will update our AMI ID as well. Let's say it is ABC version 2 XXX, something like that. And it will simply keep our desired size, max size as same as the previous one. So and then we run the terraform init plan and apply using the our bash script, our standard ways, whatever ways you are following. So you can um, so this is going to be a little bit of Python script. The second part would be terraform apply with the updated configuration on our file. So if when you do this uh, apply, it will make sure that it creates a new node group. And once that is done, now the next step is to ensure and to do the the migration of pods, the running pods to our new node group. So how do we do that? For this, again, we can create a simple bash file, bash script, which will iterate over our older node groups and run the drain and delete command one by one. Here, so this step gives us a lot of control. Like how do we want to handle this? And even before doing this drain and delete, we can make our node unschedulable, reschedulable altogether. So maybe at the first step, run the cordon on all nodes, older nodes. Let's say I give it number 05. So in this case, we are going to cordon the node group, nodes belonging to the node group 04. And then the bash script. Why we are performing step number 3? Because we want to cordon all the older nodes together uh, quickly. Because if there are new pods coming on, we want to make sure that they land on the new node group. Yeah, not on the older node group. Otherwise, we will have to do the migration of those new pods as well. So how do we? So I can provide a simple snippet like simple for loop for I in kubectl get nodes -l EKS node group is equal to and do, and then kubectl drain. Sorry, first would be cordon and then $i, and then it would be done. So this kind of bash snippet you can use. I can provide you the full links of these scripts, Python script, bash script. If you want to get it, please comment in the comment below in this video, and I will share this script with you. At least I will share the snippet with you, and then you can put all these in your workflow or in your master script. So this is the fourth step that will basically, and this the fourth step, like cordon, drain and delete, provides you a lot of control. How do you want to drain your nodes? Is there any specific checks? Is there any deployment that you want to delete first of all? That is very important for the other workload to run. For example, you might have some stateful sets which you want to handle in a certain way. So you can simply delete or drain or restart those deployments uh, before performing drain and delete. And also after each node, after each drain and delete is completed, you can have some health checks as well, that you are having certain number of ports belonging to a particular deployment. And after your one of the node is deleted, you want to again check the ports belonging to that particular deployment. So let's say app name is equal to XYZ. So this will help to ensure that uh, that your application is still live, or you have any custom logic to perform monitoring. That part can be done here. Um, so this is very important step. Once this is done, uh, once you have accomplished the draining and deleting of older node group, you can again check like how many nodes are still running using kubectl get nodes, and it will basically give you uh, like the desired count is okay or as per your expectation, and then you can go further to delete uh, the older node group from the terraform as well. So for that, again, you need to build a little bit of Python code which can remove this part from your terraform file, and then you can delete the older node group configuration from terraform file using Python code. So this will simply remove your node group from the console, AWS console as well, and you have a new node group with the new updated node AMIs.